Question 12, proportion, very common question. So y is inversely, which means 1 over proportional to x squared, and then we need to turn it into an equation with k over x squared. We know a y and x value, so we can work out k. So 8 equals k divided by 0.5 squared. So 8 times 0.5 squared will be k. So 8 times 0.5 squared. So 2 equals k, and then we rewrite that from here as y equals 2 over x squared. Filling in some values in the table, we're just going to use this equation twice. So y equals 2 over x squared. If we know y, we find that 800 equals 2 over x squared. We're going to swap those around to get x squared on the top. So this is 2 divided by 800, and then we will square root it to find the answer. So 2 divided by 800, and then we're going to square root that. So we get that this is 0.05. So x equals 0.05. Going the other way, we're going to use the same formula. So y equals 2 over x squared. So in this case, y equals 2 divided by 0.2 squared. And we can type that in on the calculator. So 2 divided by 0.2 squared. So y equals 50. And then we just fill that in the table as 50. Question number 13. Similar shapes. As soon as we see similar shapes, we need to be thinking about the scale factor and the links between them. So we have the smaller object and the larger object. They are the two options. Now, in terms of using the table for this question, which I've covered with year 11, but year 10 will be going through after Easter, there are 3 columns. We have the scale factor, and we have the smaller, the larger. We have lengths, we have areas, and we have volumes. We know surface area of the smaller box is 132, so we are talking about an area of the smaller object, and the length of its longest side is 12. So that's the length of a smaller object, 12. The total surface area of the larger box, so we're talking about the larger box, and the area is 297, and we're asked to find the length of the longer side, so this is x here. We can find the area scale factor by doing 297 divided by 132. So the area scale factor is 2.25. So the area is 2.25 bigger. To find the length scale factor, we need to square root that value. So the length scale factor is 1.5. And then to find the larger length, we're going to do 12 times by this scale factor of 1.5. 12 times 1.5 equals 18. Question number 14. Calculate the area of the triangle ACD. So I need to find the area of this triangle here. I'm going to have to use a half AB sine C, where A and B are 2 sides either side of the angle. So I need to find this side here. I'm going to have to use cosine rule on this triangle here because I have 2 sides and the angle in between. So cosine rule is how I will find x. Remember to rearrange your letters so that we are always looking for A. So we are always looking for A. So we have x squared equals 8.8 squared plus 7.2 squared minus 2 times 8.8 times 7.2 times cos of 84. Remember to put this bit in a bracket so that when you type it in, you work out it separately to the adding part. So 8.8 squared plus 7.2 squared. This is 129.28. Subtract 2 times 8.8 times 7.2 times cos of 84, close bracket. So that is subtract 13.24 dot dot dot. So x will equal that answer subtracted and then square rooted. So we've got 129.28 minus 13.24, so that comes out, so x squared is 116.04, so x will be the square root of that, which is 10.77, which we'll use as 2 decimal places because that's slightly more accurate than they've given us. Then we're going to use the area equals a half AB sine C. So it's a half times by the 10.77 we just worked out, times by the 18.6 here, times by the sine of the angle in between, which is 47. So again, we can just type that in. So a half times 10.7 7 times 18.6 times the sine of 47, and that gives us the area is 24.72 centimeters squared. Question 15. Sketch the graph of y equals sine x plus 3 for values between 0 and 360. So we always go up in 90s when we are sketching any trigonometry graph. So sine of 0, if I type that in on the calculator, because you can use the calculator to work this out, sine of 0 is 0. However, I'm going to add 3, so that means it's going to be at the point 3. So at sine 0, I'm going to be at 3. Try sine of 90. Sine of 90 on your calculator, it comes out as 1. Add the 3, that takes me up to the point 4. So sine of 90 is at 4. Do 180 next. Sine of 180 is 0, but add the 3, I'm going to end up at 3. Do the sine of 270 next. I'm going to end up as minus 1, which when I add 3 will take me to 2. So 270 will be at 2. And then again, the sine of 360 is 0. So add the 3 on, I get to 3. And then it's just a case of sketching that curve in between those values, and that is the sine curve. Solve the equation sine of y equals 3.5 and y equals sine x plus 3. So that means we are in effect solving 3.5 equal to sine x plus 3. So we are going to draw a line across at 3.5. Again, remember it's all sketching, so it doesn't have to be perfectly accurate. Then I need to work out what x will be from this. So I'm going to take the 3 away. So I'm left with 3.5 minus 3 equals sine of x. So 0.5 equals the sine of x. Use the sine to the minus 1 feature on your calculator to do sine to the minus 1 of 0.5, and you find that 30 degrees equals x. Now this solution here must be the 30-degree solution. We also need to find this solution here. So we are going to do 180 minus that 30. So 180 minus 30, which will give us 150 as the other solution. So x could be 30 or 150. Remembering that the gap between here and here will be the same as the gap between there and there because of this symmetry within the sine curve. Denia says the graph of sine x is the same as graph of cos of x to minus 90. Explain the transformation from cos of x to cos of x minus 90. This is to do with transformations of graphs and then applied to sine and cosine. So if we have a transformation of something within a bracket, that means we shift the whole graph the opposite direction to this. So if we have the normal cos curve, which is from 0, 90, 180, 270 and 360. You don't need this much detail, but it's just to help with the explanation. It goes from 1 to minus 1. Now, cos of 0 is 1. Cos of 90 is nothing. Cos of 180 is minus 1. Cos of 270 is nothing, and cos of 360 is 1. So the normal cos curve moves like that. Now, if we are going to shift the whole thing 90 degrees, that means it's going to shift 90 degrees, and instead of going in the direction it says, because it's in a bracket, it's going to go the opposite way. So all of this is going to shift across 90 degrees. When it shifts across 90 degrees, every point moves over from where it is currently. So that will mean that this current point, so at 0, 90, 180, 270 and 360. So where it is currently at 0, it will be at 90. So instead of being at 1 at 0, it will be at 190. Instead of being at 0 at 180, it will shift at 90, sorry, it'll be at 0 at 180. This point will move across here, and again that point will move there. So that will give us that curve there, and if we looked at minus 90, it would be at 0, so minus 90 would be here now. So that gives us that shape, and that is the exact sine curve. So what they have suggested is correct. What we would say is the transformation is 90 degrees right, and then we would say yes, correct. And that's the end of the paper.